Okay, what's up guys? I want to do some reviewing. You have a one problem assignment from this packet. Solving the inequality and graphing your solution. So, you obviously need your number line. There's only one symbol, so no table. Okay. Now on the x side, on the variable side, you got times and plus. So you highlight the times, that's a switch. So you got to take out the 8. When you're taking out the 8, you go from minus 8. Now when you're minusing and plussing, you drop the original sign, okay? It doesn't change when you add and subtract, not until you've divided by the negative. So that's 4 and then negative 4 times x. Then you divide each side by negative 4, and that's where the sign flips, because you're dividing both sides by a negative. So you have negative 1, it's eating the variable, so that would be this way. Once again, label it x greater than or equal to negative. You just copy your label. Okay, next problem. X is on this side of the inequality, that's no problem. Okay, so you got a times and a plus, highlight the times, and you have a negative, so that's another switcheroo. Now you have to take out the positive 5. So remember, when you're adding and minusing, the sign stays the same. Okay, from where it is, it doesn't flip till after we've divided. So that's 20 negative 2 times x. So now we still got to divide now by the, don't add to. Remember, if you have a negative multiplying number, you divide by the negative. You got x, negative 10. So negative 10, circle, eats the x, so it goes this way, even though that's a less than sign, it's eating the x. So. Okay, you got x's on opposite sides, so we're going to take out the smaller one. Okay, 8x, 3x, so I minus 3x. See, I don't know whether this is a switch or keep until we're down to just one single x. Okay, okay, so we line the sign up, and you got 5x minus 6, and over there you have your positive 14. If it's got a plus, just put 14. Now we can make our wall and decide what we're going to do with our sign. So we got times and minus, make it plus negative. So that's a keeper, okay? I got to take out the negative 6 first. So plus 6, plus 6. So I have 5 times x and then 20. Then again we divide by 5, and I have x and the 4. So 4 is your starting point for the solutions. It eats numbers, so that's going this way. Okay, next problem. Gosh, this goes so much faster when I actually have the packet in front of me than when I have to write it in notebook paper. Okay, you have to apply the distributive property, okay, with your negative 3. So what do we have here? Well, we got an x or a 1x if you want to put it, and then a plus negative 4. So when you're distributing, you're going 3 to 1x or x and 3 to negative 4. So you write x down, and then negative 3 times 1 is negative 3, and then 12. Okay, I know I multiply by negative, but I wasn't doing it to both sides. When you get rid of the parentheses, you drop the original sign. So negative 3x plus 12, and then 36. Okay, this is the only x, so now you can decide what you're going to do with your sign. I think that's a switcheroo. Okay, we have to take out the positive 12, so we minus 12. That's going to be 24. Okay, so divide. Remember, don't add 3, you divide by negative 3. So you got x, negative 8. So you got negative 8, circle. Okay, this remains open and it eats the x, so that's this way. Okay, next one, again, you got double x's on opposite sides, so you take out the smaller one, you minus 4x, but make your number line, you'll need that. 0. Minus 4x. So I have 2x plus 2, and then that's a negative 16. Now I can figure out what happens with the sign. You got a times 2, a plus 2. That's a keeper because it's positive. I'll be dividing both sides by a positive. So take out the plus 2 by minusing 2. And that's negative 18. Divide both sides by 2. Negative 9. Circle, fill it, eats x, so it goes this way. Okay, now we're going to run into some compound inequalities. So we have two symbols, so that means we got to make the table right below it. Don't make it to the side, that's for absolute value. Okay, now we're not going to do any absolute value here today. Hit that later. Okay, so on one side, start a circle, and then stop the circle when you get to the other side. So you just drop down what you circled, negative 6, 2x plus 4. Then start a circle from here, stop it when you get to the other side. So that side you're going to have 2x plus 4 and then 24. Okay, so you solve them separately. So you got x on this side, you got times 2 plus 4. That's a keep, okay? So keep the sign, take out the plus 4. So minus 4 from negative 6, that's going to be negative 10 and 2 times x. And you divide by 2, and you have x behind the symbol, so keep it there, and then negative 5. Don't graph that yet, we have a whole nother side we have to solve. Okay, that's another keep. And we have to take out the plus 4. So I minus 4, that takes that side to 20, and then 2 times x. Okay, now I divide by 2. So x and 10. So we have negative 5 and positive 10. So above the negative 5, it's filled. Okay, it eats the x, so that's this way. Just make a little thing going that way because we have another side. Okay, then the 10. Okay, fill it. It eats a number, so obviously that's going to go like this. And the way to label that, you put x down once with negative 5 and 10. That's your highest, that's your maximum amount. You eat that, but then you eat the x. Okay. So if you pick a number between them, don't write this down, but if you pick a number in between them, let's say positive 2. Let's have positive 2 going for x. Don't write this down. That eats between these two. The higher number is being eaten, and then here the higher number is being eaten. So that's why that's lined up the way that it is. That's verification. Okay, this is another compound, but these are separated. It's an OR, okay? Okay, so on one side, 3x plus 4 greater than or equal to 1. And on the other side, you just put negative 5x greater than 25. So that's a keep. You got to take out your plus 4. Remember, if that's a positive multiplication number, you keep it because you're going to be dividing both sides by a positive, not a negative. So it's negative 3, then we divide by 3, x, negative 1. Okay, that's a key, that's a switch, excuse me. And we can go straight into dividing because there's no number you have to take out by adding and subtracting. So you have x, negative 5. So you got negative 1, negative 5. Now give yourself some space, okay, so you can work. So let's talk about the negative 1. It's eating the x, so that would be this way. With the negative 5, it's eating the numbers, so that would be this way, okay. So I write OR, and then I just copy down what I got. So greater than or equal to negative 1. Then less than or equal to negative 5. Okay, now I'm going to go over some story problems. A salesperson has a goal of raising $500. They sell necklaces for $5 each and bracelets for $7.50 each. They've already sold 50 necklaces but have run out of them. Write and solve an inequality that gives how many bracelets they need to sell to meet their goal. So an inequality means you set it up with a greater than or less than. Put your greater than, because it's a goal. Goal is greater than or equal to. And the goal is $500. Now you need to cross out 500. You've already put that down. Okay, now what's the first money amount you got? You got 5. Does that come in multiples? Well, yeah, I plan on selling more than one necklace. Okay, so times n plus. and there's another money amount of $7.50, and that's going to come by the multiples, and that's for the bracelets, so B. So what you're selling them for. Okay, now one of these variables has to, some number has to go in for it. I have 50 necklaces, so 50 equals N, so we replace our N with 50. We need to find that product. 5 times 50 is 250. It's not 250N. The N is gone, never to return. Plus 7.50 times B, greater than or equal to 500. So you got a plus and a times. Those are your operations. The times is by a positive, so that's a keep. Now you have to take out your 250 by minusing 250. So $7.50 times B, that's going to be 250. So divide each side by 750, 750. Okay, I want whole numbers here, not decimals, because a bracelet would be discrete. You can't buy decimals for bracelets. So when we have a goal, a greater than, we want to raise it up 1. Okay, we don't care, we don't do our traditional rounding. Okay, it's raised up to 34. And that would be our goal. So I can sell 34 to meet the goal dead on. Then it's eating the B, so it'd be anything that way. So B greater than or equal to 34. Okay, we did one like this last week too. My goal in science class is to receive a 93 average for my test. So far I've received grades of 85, 97, and 88. Write and solve an inequality that gives the possible scores I could receive on my next test to meet my goal. So again, the goal is greater than or equal. Now what is your goal? Your goal is 93. Now, you don't want to just start writing in numbers here. You need to write the word average up here, because when we add them all up, cross out the 93, that's placed. So how many tests am I taking? I've taken 3, but I'm about to take number 4. So I need 4 things on the top. Well, I've got 3 of them right in plain sight. 85 plus 97 plus 88. And then I don't know what I'm going to get, so I use a variable, probably just X. Now, you're not actually ever going to be able to divide because you don't have the X value. But you can add at least the numbers you have. Don't divide them by 3 either. You just add them and leave it. 270. So now I have the expression X plus 270 over 4. Now, I have a whole parentheses here. Now, I know what to do when there's a number times a parentheses, but what I do in a parentheses is divided by a number. Well, you multiply so you can get rid of the divided by 4. So you've got X plus 270, and then 93 times 4 is 372. Okay, so your wall here, you don't even have multiplication. You can put a 1 if you want, but it's a keep. Okay, you got to take out the 270. So you got X, and that's going to be 102. I think this guy's not going to be able to meet his goal, probably. Okay, unless the teacher's offering extra credit, but you still solve it. Now, if you have a 1 in front, you just divide by 1. It's still 102. So eats the X. So you get 102 or higher. Now, if that's not possible, it's not possible, but we solved it. Okay, I have 120 yards of fence to put around a rectangular deer plot. Draw the rectangle, label it length, length, width, width. The length of the plot's 25 yards. Write and solve an inequality that could be possible widths of the deer plot. So when you have something that's a less than or equal, because you can't go over 120 yards. Now you don't just start throwing in numbers. You have to go up to your rectangle. Okay. Now we're putting the fence, cross out the 120. We're putting the 120 yards around all 4 sides. So there are 2 times the lengths and 2 times the widths. So we have 2 times L plus 2 times W. So if you're wondering how I get that, well, it goes around all 4 sides. 2 of the sides are L, so 2 times L. 2 of the sides are W. Now again, that 25 goes in for one of the variables, and it would go in for the L because it says that's the length. 2 times 25 then is 50, so now I have 50 plus 2 times W less than or equal to 120. So you have plus and times, okay? So that's a keeper. We do have to take out the 50 though. It's a plus 50, so minus 50. You don't add 50 because that makes 100, okay? So 2 times W, 70, then divide by your 2, and you have W with 35. So you have to make your width 35, and since it eats the number, anything less than 35. Now obviously it wouldn't be negatives, but don't worry about that. Now here's a new problem. Okay, I'm going to wait till this gets to the 16-minute mark, because the afternoon I think is off schedule. Okay, 16-minute mark. The ideal length of a certain length of nail is 20 millimeters. The actual length must be within 0.4 millimeters of the desired size. Write an inequality that describes the range of the acceptable lengths of the nail. Okay. Here's how a range needs to be set up. Okay. You first need to make your number line. You're not going to put 0 though. Okay. Don't put 0 because 0 is not going to fall into this range. Now think of a wrestler. Here's what another thing range means. Let's say a wrestle heavyweight, you have to be 275 pounds, but you can be 20 pounds over or 20 pounds under. So you could be at 290 or 250, anywhere in between to wrestle. So that's essentially what this is all about. Now this within stuff, okay, when you see the word within or variation, either one of those words, you put a plus or minus 0.4. You just put that up here. Alright, now, and then you can ignore the 0.4 as long as that's there, okay? Now your length is supposed to be 20, so that actually goes in the middle, but there's a maximum and a minimum. So to find it, it's pretty easy. You just take 20, 20, plus, minus, and then the number you plus minus is up there for you, 20.4 and 19.4. So 20.4 is the maximum acceptable length. That's 19.6, I'm sorry. 19.6 is the minimum. And you just make a graph where they go towards each other, they're between. Now, you use the L variable, you don't put 20 anywhere in here. Okay, 20 does not go in the label at all. So L, you put 19.6 on one side, 20.4 on the other. You can even slash out the 20, but because you don't use it. So you eat the higher, then you eat the lower, and it's done. Okay, this is the answer with the graph. Okay, next problem. The ideal length of a horse fence is 300 feet. The length must be within 5 feet, so put plus or minus 5, cross it out, of the ideal amount. The ideal width is 450. The width must be within 10 feet, so you're going to put plus or minus 10, cross it out. Write inequalities for the range of both the length and the width. So you got 2 number lines you're going to make. Dude, don't put 0 in the middle, okay? This is how to set up range. What's your length supposed to be? 300. What's your width supposed to be? 450. Now to find the maximum and the minimum, you put your 300 twice. And and for the 300 you add 5, so you're going to add 5 and subtract 5. So it's 305 and 295. So we place 305 here, 295 here. Now you want to cross out 300 now. You've already used that, it's done. Okay? It's all about the minimum and the maximum. Then you put L for your variable, 295, 305. Then you eat the max and eat the letter. Now you have another one to do with your 450. Now you're going to go 10 with that one because you can be 10 over or 10 under. So that's 460 and 440. So 460, 440. And cross that out. After you know what the minimum max, you don't need that one in the middle. You're not going to use it anymore. So use W for a variable, because a lot of people put 450 there. Okay, no. Width means you need to have the variable W. Eat the max, eat the W. Okay, you're done. Okay, it goes pretty quick. A manufacturer is cutting metal into rectangles that are 20 inches long by 35.25 inches wide. Each metal's length must be within 0.25 inches. So write that up there, then cross it off so you're not confused by what you're doing down here. Write inequalities that describe the acceptable range for the length and the width. Range, there'll be a middle to start with. Wind up crossing out the middle. Long means it's the length. Long and length mean the same thing. Wide means width. Now find your minimum and maximum. Now you're going to use the 0.25 because that's the only within variation we have. So that's 20.25 and that's 19.75. So 20.250. So anytime we see a range, it's going to be one of these type of problems. 19.75. Now ditch your 20. You don't need that anymore. And label it with an L. So 19.75, 20.25. Eat the max, eat the min. Now here I take my 35.25. That's in the middle. And I add and subtract, and since I don't have a new value, I use the 0.25 again. So if you only have one within value, your variation is what that's called. Okay. You're going to go with that. So it's 35.5 or 0.50, and that's going to be 35 even. So the maximum this can be is 35.50. The minimum's 35. If it's outside there, then you got to send it back and redo it. Okay, did cross that middle one out. Put W, you're going to have 35 and 35.50. Then you eat the max and eat the W. Okay, and then the last one. One thing I want to put up here, before you write the plus or minus, put variation. Okay, that's what that's called. It's plus minus. You always have to find it when you have to find the range. Okay. The ideal circumference of a woman's basketball is 28.75 inches. The actual circumference may vary. Vary and within mean the same thing. By at most 0.25 inches. Vary and within mean the same thing. So if you see the word vary, that goes up there. Cross that out. Write an inequality that describes the range of the circumference. Okay. Anytime you're finding a range, you have to have variation. Okay. Within also means variation. Okay. So you're supposed to put your 28.75. We add, subtract. Well, pretty obvious what we're going to add and subtract. So this is 29 even. That's going to be 28.5 or 50. So 29, 28.50. Cross the middle out. We don't put that. And put it, so C, 28.50, 29. Okay, you just have one problem to do in this. Okay. Again, there's that within. That's your, put variation up there, please. Variation, plus or minus. Vary or within means that's the number.